everyone, it's Digitrax Dad back, and just a quick update. I had a couple of questions about the digital command control drawer and how that's set up, and work on that's finished now, so thought I'd just give a quick update. So let's have a look. Okay, so first up, construction. Drawer's made out of an MDF, a fascia board, which is a 3mm MDF, and which is medium density fiberboard. I've undercoated that and then given it a couple of top coats. The colour there is a sort of a slate grey. I just got a sample pot to see if I like the colour, and then I'll get a proper flat or matte finish for that. Just some pine to make the drawer structural frame, 35mm square section, and then some drawer runners that are basically off of an old IKEA set of drawers. And those sort of drawers are these type, which you may have seen it come in a pair of drawers. I got an old runner off one of those, put it onto this layout drawer, one at both ends of course, and one on the layout board itself. Okay, and on the front fascia we've got a UP5, Universal Panel 5, and that's for plugging in throttles to dispatch and acquire locomotives, because I'm using now the superseded UR91, which is the simplex Digitrax radio throttle, which simplex just simply means it transmits but it doesn't receive. It's not a two-way system, so to acquire a locomotive I need to actually plug my throttle into one of these throttle ports on the front and acquire a loco. Then I can disconnect, and I'll do that in another video, but that's pretty straightforward. And finally, the other front panel I've got is a loco net repeater, which I'm using to separate my loco nets into 3 separate loco nets, and more on that later. But basically it just helps with troubleshooting. It also helps divide up the layout. If I have a loco net problem on one board, it doesn't shut down all the boards, and it helps protect computers and the command station too. So inside, everything's wired up and labelled. We've got our 2 Digitrax DS64 stationary decoders here. You'll also notice too that I've labelled the turnouts on them. Turnout 18, 17, 16, 15 corresponds with the 4 turnouts over here, and over this side we've got 14, 13 and 11 wired together because it's a crossover, 12 and 10 wired together because it's a crossover, and turnout number 9, that's the blue and black wires. Off they go into the IDC for the connection to the ribbon, and you'll see that in one of my previous videos. Purple and white wires are both for auxiliary connections, and we'll connect them off to the layout too, and they head off via the same IDC board as well. So that's all hooked up. Power supply, you can see, is through the auxiliary jack supply, and that then runs across and into this terminal strip over the back here. Everything's labelled, so DS64 101 and 102 are both connected together because they can share a power supply. The UR91 and the UP5, once again, they can share a power supply as well. The LNRP will have its own power supply. Next board along on the loco net is the block detector, the BDL168. That's been wired up now. It's got the loco net connections, and it also has the block connections out to the layout. So what I've done is label those. Zone A is simply A1, A2, A3 and A4, and I've done a video on how I wired all of that up. All of those are wired in, and then our commons, our blocks are DCC in for A, B, C and D, and that corresponds to these A, B, C, Ds here. So basically splits them into 4 to go out to the layout. Also we have power to the board, which is our 12 volt DC connection in, and our earth or common connection here, which runs underneath the adjacent Sigma 20 board and across to the terminal strips here where it connects to the layout. The common zones come from this PM42 board, which is the power manager, which is divided into 4 zones. So the 4 black wires off of here, which you can see on these 4 terminal strips, they come in underneath the board and along, and that's zone 1 off of the PM42 is zone A, zone 2 is zone B, etc., coming from the PM42 to the BDL. In the middle of all that, we've got our SIGM 20, and there's a separate video I've already done on that. That's our signal logic control board. That's been wired up with logical color coding, which is the red, yellow and green wires for the red, yellow and green LEDs, and the black being a common for each of the groups of signals. Every signal's been labelled here, so I know which one it goes to, and I've kept a spreadsheet of every number of these IDC boards, which part of the ribbon cable it connects to. Everything's then hooked up with LocoNet cables, so coming off of the LocoNet repeater module, we've got basically a daisy chain effect. So coming off of here, we go down to the UR91, we go from the UR91 down to the UP5, cross to the PM42, then to the SIGM 20, up to the BDL168, and then to each of the Digitrax DS64 boards, and then the next daisy chain starts here at the back of the LocoNet repeater module and then goes off board, and as you can see from the marking, that goes from the LocoNet repeater board 1 to the DB150, which is the booster. The boosters are down over here, and the cabling for those will be wired up also over here. So the DB150's on the right, the DCS 100's on the left, and a bit of wiring to do there. They'll be powered from this PS 2012, which is going to supply power to both those boosters there. So that's about it. That's the update. This drawer's all ready to go and finished. We're simply now in the mode of doing all the wiring on the module that board controls. So you can see just quickly, we've got 10 tortoise motors here. All the tortoise motors are wired up. All the track feeders for the frock change of polarity are all wired up too. We've got our ribbon connectors. This is where the drawer will connect into these terminals and the IDC boards. And then also all of these tortoise motors all wired up. All the frog feeds. I haven't finished yet, so I'm going to make it look a bit neater. This is the sort of wiring I do, where each wire is labelled, each track feed's labelled, which detection zone it comes to, all the block detection commons, the red zone wires are all in place, and then each of the black wires indicating one of the 16 detection sections of a BDL168 are also labelled as well. Each turnout you can see is labelled, just to make it as clear as possible. All of this is captured on my design drawings. Each board is up there on the wall, so I know which LocoNet cable goes where. I've colour coded my LocoNet cables, and as you may have seen in one of my previous videos, each block detection system section is labelled, as well as every turnout and every signal, just to make it clear. So all of that's on my wall. We'll get into the architecture soon of the control panels, which is with another proprietary product, and that'll be a subject of another video down the track. Anyway, I hope you enjoyed the update, and yeah, we'll stay tuned. More from Digitrax Dad. Cheers.